Question 20. We're told this is the curve y is 1 over x, and we can see that we have rectangle below and rectangle above between n minus 1 and n. We're asked to use the diagram to show that e to the negative n over n minus 1 would be less than 1 take away 1 over n to the n, which is less than e to the negative 1. We can see that the area of this rectangle would be less than the area of the whole rectangle. In between the two would be the area under the curve. The height of the rectangle here is 1 over n because the x-coordinate is n, and here it's 1 over n minus 1. The width is 1, so the area of the small rectangle is 1 over n. That must be less than the area under the curve, which is the integral from n minus 1 to n of 1 over x dx, and that would be less than the area of the large rectangle, which is 1 over n minus 1. So we have 1 over n is less than ln x to be evaluated from n minus 1 to n, and that's less than 1 over n minus 1. So 1 over n is less than ln n, take away ln n minus 1, and that's less than 1 over n minus 1. So 1 over n is less than ln n over n minus 1, just using log laws, which is less than 1 over n take 1. Now it can be difficult to see where to go algebraically from here. What I'm going to do is take the negative of all three terms, and hopefully that will become clear later why we want this. Remember, if we multiply all of these by negative 1, we need to switch the inequalities, so this one will come to this end. So that's negative 1 over n minus 1 would be less, if we take the negative of this, it becomes n minus 1 over n. And that's the reason for doing it, because this will give me what's in the bracket here. That's going to be less than negative 1 over n. And now take the exponential right the way through. So we get e to the negative 1 over n minus 1 is less than n minus 1 over n, which is less than e to the negative 1 over n. So that's e to the negative 1 over n minus 1 is less than 1 take 1 over n, which is less than e to the negative 1 over n, and now just raise all three to the nth power, and we get e to the minus n over n minus 1 is less than 1 minus 1 over n to the n, which is less than e to the negative 1, as required. Now in part B, we want to deduce the limit as n tends to infinity of 1 take away 1 over n to the n. So we have n tending to infinity. That means that this expression here will tend to 1, and therefore the whole thing here will tend to e to the negative 1. So this is sandwiched between e to the negative 1 and something approaching e to the negative 1, so it must tend to e to the negative 1.